This, again, it's going to focus on what Britpave members are doing to not only address the challenges, but make those challenges into opportunities. And our first speaker of the day is David Wilson from Tarmac. And he, again, is going to underline the innovations and new developments which Tarmac are doing in reducing the CO2 of cement manufacture. David, thank you.
Okay, so Tarmac Cement and Lime, Britpave decarbonisation. I'd like to thank Britpave for the invite today and say hello to everyone. The last presentation I did was in Manila, believe it or not, which was a fantastic opportunity just to thank everyone for the envelopes. Right, so introduction. So I work as the business development manager in Lime, and the Lime is the area where I'll focus. Happily married with 2 kids, 16 and 13. Unusual names, but I think they'll get used to it. And that's what we're going to cover off today. So cement and lime are carbon-intensive industry from both the fuel and the process. Government's legally obliged to meet the net zero targets and to achieve a 68% reduction versus the 1990 levels by 2030. And this requires a huge industrial shift, a 95% drop from 1990 levels, although we have clearly made a lot of progress to date. And that just shows, that graph doesn't come up very well, but it just shows the red dotted line is the 80% trajectory, and the green is where we need to be. So it's a huge, huge challenge. So the CO2 agenda is growing publicly. Everyone's mentioned it earlier today, and the government is responding. Industrial CO2 emissions represent extremely good value for money for the government to invest in compared to the more challenging household emissions. Cement's considered a top 3 industrial target, 1.5% in the UK. Number 1 is steel, and number 2 is ammonia and petrochemicals. And all of our clients are now demanding low carbon products. And that just shows the pollution that's happened since 1750 with carbon dioxide, methane, and nitrous oxide. So decarbonisation, how else can you show it? But it's a massive, long, windy road. It's going to require huge investment, huge innovation, huge risks. But we'll get there, and we are aiming to get there. So one of the key challenges we've got is decarbonisation. So what do you have to do? You have to capture the CO2. So that's either end a pipe or change your process completely. You then need to treat the CO2 to meet the specification. That specification being for either rail or road or pipeline. And that's not easy. The specifications for CO2 are incredibly tight. You then need to transport it, and then you need to either use or store it. And because the volumes involved in the cement and lime industries, storage is really the only way forward. You also need to have a good framework in place to have a successful project. So one of the key challenges we've got is the process emissions. A number of approaches to this, and there's various zero and low carbon fuels that we can use. But the nature of the process and the calcination element means that ultimately you've got to find a way of getting hold of your process CO2. That's the big challenge. So for example, for lime, a lime produces 950 kilos of CO2 for every tonne of lime that we produce. So it's practically a tonne per tonne. For cement, I think it's a bit lower, about 750. And of that total CO2 for lime, 75% of our emissions come from the actual process, and 25% of them CO2 emissions come from the fuel. So another challenge for us is location. Once you capture the CO2, the left-hand side is enhanced oil recovery. That's the left-hand black line. And the right-hand black line is the CO2 injected for deep storage. Now, you won't be surprised, but all of the CO2 for deep storage is in and around the coastline of the UK. So if we look at the government super places, these are the amount of CO2 that can be captured in various industrial hubs in and around the UK. Many of you will have seen this drawing before. But you see Merseyside got 5 million tonnes of CO2, Humberside and Teesside, around about 14 million tonnes. Now, our lime business is right in the centre of that. It's what you call a dispersed site in the middle of Buxton. So that represents quite a unique challenge. And this is the government's industrial decarbonisation strategy that was launched in March 2021. And the blue circles show where they are doing the CO2 storage. You can see there's nothing south of Liverpool. And you can see that for the first time ever, the Peak District, which is where we're based for lime, has got something going towards Merseyside. So they started to recognise dispersed sites. So in terms of the scale, this is a CO2 concentration map. The red dot on the left is the northwest CO2, and the right-hand red dot is the Peak District, which consists of Tarmac Cement and Lime, Breedon Cement, and Lowast Lime. Now, we've heard a lot about collaboration. What we've done is we've formed something called a peak cluster. So the peak cluster consists of 3 companies. So instead of just having around 1 million tonnes of CO2 per year, we've potentially got 2.5 million tonnes of CO2. And that's where 3 companies across 4 different sites are situated. That is a really good example of collaboration. So 2.5 million tonnes from 3 cement and lime companies. And it's got us going towards HyNet. That's a picture from HyNet's website, which shows all the development they're doing with the hydrogen and SR and the CO2 being captured and deep stored beneath the ocean in the depleted oil and gas reserves. So the goal is to develop a shared CO2 pipeline to transport the captured CO2 to the core HyNet system for permanent storage. Why are we doing this? We're trying to address the challenges of dispersed sites through collaboration, recognising the infrastructure needed. And it's a proactive push towards government for support. Funding is a huge challenge. For them, 3 companies across 4 sites, we're probably talking of funding in the region of about £1 billion, which is absolutely phenomenal and will not add up without significant government support. And that's why we've got Scrabble there, really, because the government support mechanisms, you need to try and look at them all and try and make a word out of them. So you may have come across these just to give you a little flavour for them. We've got the Industrial Energy Transformation Fund, the CCUS Innovation 2.0, Carbon Storage and Infrastructure Fund, the Industry of the Future Programme, and Net Zero Innovation Funding Portfolio. They're all designed for different niches of development and progress. There's a lot of money within the government, and there's a lot of money being pushed towards making these things happen. Government mechanisms are a huge challenge. Are they going to do a contracts for difference model like they did with the offshore wind? How do they encourage early movers, first of a kind technology? Where are the risks and liabilities? Where do they sit? New commercial frameworks being promised to give a little bit more confidence and support by 2022. As it stands today, the economics of investment just do not stack up based on the incredibly high capex costs of the capture, transport and storage and the lower carbon emission charges. This graph was taken from the Financial Times, which shows the CO2 pricing at around about £57. Only in the last couple of weeks it's gone up to the high 70s already. So the scale on the right-hand side is already out of date. But it's likely that the carbon pricing will just keep on increasing. And this will, in turn, make CCUS, carbon capture, utilisation and storage, more attractive from a capex investment perspective. Infrastructure, we're quite lucky in the UK. We've got a strong opportunity to lead. As compared to many other countries, it's well placed. We've got oceans all around us, and we've got lots of depleted gas and oil reserves. So we've got good geography and geology, skilled workforce, Environment Agency and permitting, energy networks, which are quite comprehensive, which you can see on that graph on the right-hand side. So HyNet, You will have heard about HyNet in the northwest. There's three key players really. There's the ENI, who are the Italian company who own the depleted gas and oil reserves off the northwest. So they'll be heavily involved in any potential pipeline. SR, which they've got Stanlow oil refinery where they've got significant government support to invest in a 3 terawatt hours hydrogen production using Johnson Matthey technique. And Progressive Energy, who are the consultants leading the charge, if you like, for the northwest. So we can overcome the issues, and we do need commitment, and we do need fundamental commitments and fundamental need to take action. So alternative fuels was touched on. So since 2015, Tarmac cement kilns using alternative fuels have burnt 500,000 tonnes of alternative fuel, leading to a reduction of 35,000 tonnes of CO2. The sort of fuels that we've burnt and are burning currently is like waste wood, processed sewage pellets, recycled liquid fuel, meat and bone meal we used to burn but we don't burn anymore, tire-derived fuel, which has still got beneficial properties for cement kilns, and the main one is the bottom centre, solid recovered fuel or SRF, where at Tunstead we've got our own unique SRF plant that brings in specific waste streams, blends them, shreds them to a specification, and then feeds the neighbouring cement plant. The other elements that are still important is clinker factor reduction, increasing the kiln economy, and also increasing the alternative raw material usage. These all help in terms of reducing CO2. Hydrogen, we've heard hydrogen being mentioned. So hydrogen fuels in 2020, Tarmac Lime was successfully awarded funding by Bayes to explore the viability of hydrogen as an alternative fuel to natural gas. We're looking to demonstrate hydrogen fuel and the lime manufacturing in the sense that it's environmentally robust and a means to assess the technology feasibility within the sector. We chose our elderly vertical shaft kilns to trial the hydrogen. That's the vertical shaft kiln for a lime. And some of the challenges with hydrogen include the gas density, flame speed, flame temperature, and the impact on kiln performance and product quality, and the long-term embrittlement and degradation of materials in the kiln systems, including potential damage to the refractories. Production, storage, and logistics of hydrogen at competitive prices is also a significant challenge. Most of the hydrogen in the UK is made using SMR, steam methane recovery, which is obviously using natural gas, which is sky high at the moment. Plus, you've got the added cost of carbon capture on top of that, so you're not doing any environmental harm. Carbon capture, just want to touch on this. This is a massive subject, but we're going to be launching a pre-feasibility and feasibility study for Tarmac's Tunstead Cement and Lime operation, which is shown in that picture. So you can see we've got 8. I'll show you. We've got 8 shaft kilns there. We've got a Mertz kiln there and a cement plant there. So the types of carbon capture to be considered are post-capture, which is monoethanolamine, which is end-of-pipe solution using solvents that captures the CO2. The second one is oxygen enrichment, where you're replacing air in the kiln with oxygen, so you're getting a lot purer CO2 out the back. Carbon looping, which is, it's not in its infancy, but it's not got a very high technology readiness level, where you're switching between calcium oxide and calcium carbonate. Indirect heated kiln, which I've got a slide on, or any combination of the above. So indirect heating, which is LILAC, which stands for a low emissions intensity lime and cement, European funded project that's been within the framework of the Horizon 2020 European Research and Innovation Programme. And Tarmac were one of several founder members back in 2016. So it's a very small footprint of a kiln, probably 10 metres by 10 metres, but around 80 metres in height. Basically, instead of dropping your cobbles of limestone in, you're dropping elements in that are around 140 micron. So you're dropping a very, very fine powder in, and it's a flash calciner. So Calix are the ones that they are leading that patented technology. They're an Australian company, and they've got a good track record. So we've got a nice drawing here that shows you the kiln. So Tarmac have now agreed terms and signed a memorandum of understanding with Calix to conduct a front-end engineering design study for the feasibility and design of a calyx direct separation lime calciner capable of producing lime and capturing all the processed CO2. So in short, the process is very innovative and very different. So you're heating the actual outer tube instead of, and that's where you get the calcination, flash instantly calcination, instead of either heating the material inside there. So it allows for a much easier capture of all the CO2 process emissions and is therefore an important step towards our decarbonisation goals. In lime in the UK, everyone uses natural gas. Limestone produces a relatively purer stream of CO2 compared to cement because they've obviously got all the alternative fuels and the benefit and the effect that has on the flue gas composition. And then my final slide, which lays a nice introduction for Rebecca, is recarbonation. So both cement and lime recarbonate at the point of use. And a Euler study concluded that natural carbonation of lime captures, on average, 33% of all processed CO2 emissions during production. So for lime, remember we said a ton of lime gives a ton of CO2. And we also know that 75% of that CO2 is from the process. So by capturing 33% of that through recarbonation as it's being used by our customers, effectively 250 kilos or a quarter of the amount of CO2 that's produced is gained back through recarbonation. Sadly, it's not currently recognised as a CO2 benefit in terms of what the customers do or benefit to us for the properties of the lime. So that's what we've covered off. I know it's been a real whistle-stop tour, introduction, background, key challenges, opportunities, carbon capture, technology shift and net negative. So thank you very much.